Hello. Can you guys hear me?
Yes.
Yeah, all good.
Thank you for being here, Peleus, and your contribution in the networking. I think I met you last time around there too.
It's good to be back.
Let's see. So let's wait for a few more people to show up. Closing in on 1:30. All right, we can go ahead and start. Thank you, Peleus, for being here today. Today, he will be discussing deploying a scalable binary fuzzing infrastructure. I'll give the floor to him. Thank you.
Thank you for having me. Yes, my name is Peleus Uhley, and I am a principal scientist on Adobe's Vulnerability Labs team. And as was stated, we're going to be talking about deploying scalable binary fuzzing infrastructures. Now, deploying cloud-based fuzzing tools is not a new thing. People have been using them for a while. They are used by both professional organizations as well as bug bounty hunters. If a bug bounty hunter thinks that the money that they will get from deploying in the cloud will offset the costs of running in the cloud, then they will use these tools. And there are lots of different cloud-based fuzzing tools available. You can run generic tools at scale using tools like Axiom. There are multiple binary fuzzing at scale tools such as OneFuzz, ClusterFuzz, and Laniakea. Those are created by Microsoft, Google, and Mozilla respectively. There are commercial tools out in the market for this, and people have been building their own for quite some time. I gave a talk at Black Hat a few years ago about building scalable infrastructure in the cloud. So the advice I'm going to give in this area would actually apply to most of these scenarios. I am going to focus on OneFuzz because it's the project I'm working on at the time. But they are things that would help you regardless of what sort of large project you want to go after. And the other thing that I thought would be useful to discuss, since part of this is job networking and learning about job growth, is discussing not just the technical aspects of these tools, but also how you would deploy them in a large organization. So most of the time when you hear about these tools talk to conferences, they're talking to other industry professionals who already have some experience in deploying tools within organizations. But since this is mostly college students, I figured it'd be good to give some background on things that the management is going to consider when you propose these tools. Because you're going to go to Black Hat or DEF CON and you're going to see some cool tool, maybe at OWASP, and you're going to come back and like, oh, this is awesome. We really need to deploy this in our organization. And your manager might just give you a look like this, like what are you talking about? I don't think this is right at this time. And you may not know why they're pushing back or why they don't see why this would be a good tool. And so some of this talk, in addition to the technical aspects, will sort of highlight things that your management's going to be looking at when you propose these types of projects to them. And the first thing that the management's going to look at is it the best project for the team to work on at this time? There's 1,000 different things you can do in the security world, and everybody would love to be doing them all simultaneously. But depending on the size of the org that you go into, they may not be able to do all of the things all the time. They'll have to select which projects they want to do in which order to get the most value out of their time. And so, I'm going to spend the rest of this talk talking about why fuzzing is good and why you should be able to do it. But when you're talking to your management, they may push back for why not to do it. Some of these things may just be simple man hours and dollars, such as resource constraints, expertise constraints, or monetary constraints. If you're going to go deploy these things into the cloud, somebody's got to pay for all that cloud infrastructure. And those things are hard, and you can work through them, and you can sometimes work through the timing of those to make sure that you have the money when you need it. But the other thing is actually looking at the projects you're going after. If you think about your first fuzzing run, what's going to happen is you're going to do some fuzzing, you're going to find some cool bugs. Hopefully you'll see some trends in those bugs. Those trends will identify that you need to maybe make some architectural changes, maybe you make centralized data validation a thing, maybe you have to change the coding standards a little bit. And then those things are going to get deployed, and then you're going to do another fuzzing run to see if all those things worked. But if your project's not that mature, maybe it's a project that's just getting started, maybe it can't even completely compile yet, then you can probably skip over that first fuzzing run and go directly to the things that you know that team's going to need for a strong foundation. So instead of starting with fuzzing, you start with things that can be done earlier in the process, making sure they have all their best practices around compiler flags and band functions. You can get them started early on data validation and security libraries. Maybe even talk them into using more memory safe languages like Rust or Go instead of going with C or C++. And this will have a much greater impact in establishing a solid foundation within the code that you're working with and with the team that you're working with. And then you can use fuzzing a little bit later once that you have that strong foundation in place and you're just looking to find the places that you missed. So there may be reasons why someone might push back on fuzzing. You sort of need to know what those things are and predict what those things are when you go talk to your manager so that you have answers for them. And maybe you can make the counter argument for why you should move forward with this project. But let's assume the manager says, yes, we're going to go forward with this. Let's do it. I'm all in. The next part is going to be the technical evaluation. And if you're an entry-level engineer and you're coming into the company, chances are you're going to be the person who's going to be doing the technical evaluation. The manager will review your work, but you're going to be the person whose hands on keyboard making the decisions around these things. And that's awesome, right? Everybody wants to be the hacker. Everybody wants to be at the keyboard looking for binary bugs. If you have the time, you not only want to find the bugs, but you'll try to figure out how to weaponize them. And that's great. That's the part that everybody loves. That's why you're all in this degree program. That's why you're all in this conference. But there's a lot of questions. This can be a very deep field. There are people who specialize just in doing this sort of stuff. And so, the questions become up about like which fuzzers are reliable. People have been doing fuzzing for decades. Not all of the projects are actively maintained. Do you need to run multiple types of fuzzers? And I'll get into the different types in a minute. Are you going to be okay running these manually, or do you create automation? And what kind of automation do you need and what scale? Obviously, I'm going to be talking about the automation throughout this talk. Do you do targeted fuzzing, going after specific areas? Do you do random fuzzing? What compiler flags do you need to have set? A lot of these tools look like they're focused on Linux, but maybe you're deploying on Windows, and will these tools help you also find bugs in Windows environments? How many and what features do you need out of the fuzzers? How many iterations do you think you're going to need to run this for? Is this something you can run for a day, a week, a month? Is this something that's continual year round? So there's a lot of choices to be made. And we'll get into some of these choices. So, the first thing to do is the scale of the fuzzing. So one approach might be to do random fuzzing across the entire file. So if you're going after JPEGs or images or movie files, you can do random fuzzing across the entire file, just flipping bits randomly throughout the entire thing. This will cover more of the code base because you're attacking every aspect of the file. It's sometimes really good for finding unknown unknowns. We talked about doing that proactive security work, but the proactive security work assumes that you know everything that you need to go after. This type of approach doesn't have any biases in it because you're just going after everything. So you can find those unknown unknowns. You can get some insight into the stability of the project by going after the entire thing and seeing how much you have to mutate the file to get it crash. But there are some cons to it. So you often require a more scalable infrastructure and time to deploy for these sort of things because you may be fuzzing data that's in the file that's never really parsed or edited. So if you're dealing with like a huge text file, you may just be changing the wording in the file, and causing misspelled words isn't going to cause the application to crash. You're looking for the parts to actually get interpreted. It can create some noise, and it can be hard to tune because you made the decision not to go after specific areas. You're going at it very randomly, so you have fewer options available to you for tuning. And then the alternative to that would be targeted fuzzing. And that's where you go after critical sections of the application. You're not fuzzing the entire file, you're just fuzzing a subset of the functionality in that file. And targeting fuzzing has some pros to it in that you can handle more complex scenarios. So if I'm just flipping random bits, I may never trigger a bug that requires multiple bits to be flipped in a specific way at a specific time. If you're doing targeted fuzzing, you can understand the data format and the object that's involved, and you can manipulate based on knowledge of the actual object so that you are correctly mutating into different states. And you tend to get less noise because you're focused just on the areas that you care about. Of course, the cons to this is, doing all of that tuning is going to require more bandwidth. It's going to require a little bit more coding. It's going to require platform expertise. You're going to need to be able to compile the code yourself. You can't just grab a binary and go at it. And there's opportunity cost because, again, you're applying biases where you're going after areas that you think are critical, and you may be missing something else because you're choosing not to look in those other areas. And if you go and look at the suite of tools that are available, there are several tools for all these different options. So if I was going to do black box fuzzing where I know nothing about the tool, I know nothing about the source code, and I just want to do a very quick, very dirty bit flip approach, I might go for a tool called Redamsa. This is one of 4 tools I'm going to talk about, which tend to be the more popular tools, but there are definitely dozens and dozens of tools out there. And Redamsa is a general purpose fuzzer, and it's very simplistic in its approach. You give it well-formed data in, and Redamsa gives you malformed data out. So you send in the well-formed data, it starts randomly flipping bits, and it gives you randomized output. So I have a simple example at the bottom where if you give it AAAA, and you pipe that to Redamsa, it might come back with caret AAA. So this is a good way of just like streaming random data into a tool. Now, Redamsa does have a lot of options, which I'm not going into, where you can say how many bits do you want to flip in each mutation and how many iterations do you want to go through, etc. But this is the general concept behind it, is you got well-formed data in, malformed data out. You can point it at anything without really being too concerned about what it is you're pointing it at. If you want to be gray box, where it's a little bit black box, a little bit white box, there's a tool called AFL, American Fuzzy Lot, and AFL++. AFL++ is a fork of AFL that's maintained by the open source community, where they've been adding a lot more features. And most people, when they talk about AFL, they're actually talking about AFL++. And this is a tool where it does require some access to the source code. So what you're going to do is you're going to compile it, not with generic GCC that from the open source community, but you're going to compile it with AFL's version of GCC. And because you're using a custom compiler, it can inject things into the binary that will help the fuzzer make decisions about how to manipulate the code, because it's actually compiling the code, so it can do markups and notations that will inform the fuzzer about what would be good strategically to do in terms of manipulation, what would not be. So, okay, these 8 bits represent an integer. So, you're going to do integer-based stuff. These 8 bits represent text, so you're going to do text-based stuff. It does support black box, so it's a good tool if you want to do a little bit of both. And it tends to be decent at black box testing. But once you get your binary built, you've got it instrumented with their GCC, like running it's fairly straightforward. You just do AFL fuzz, -I, the inputs you want to send into it, -O, where you want the outputs to be stored as it finds stuff, and then you just give it the path to the program. It's often compared to another tool called HongFuzz, which is very similar. People will have spirited debates about which one's better. They are both good at different things, and which one's better depends on the time in which you ask, because they both have pretty active communities behind them. But it is a gray box. It's similar to AFL. It's supported by cloud-based fuzzing tools such as ClusterFuzz. It's got an impressive list of vulnerabilities that people have been able to find using it, listed on its website. And it's also inspired a bunch of variant implementations. People have created forks of this tool for different reasons. And then there are pure white box fuzzers. So one very popular tool for white box fuzzing is called libfuzzer, stands for library fuzzer. And it's actually a part of the LLVM and Clang project, if you know those tools. And this one, because it's going after libraries, requires a lot more work on the part of the person who's doing the fuzzing, because since you're going after a library is not a standalone application. So you have to create the standalone application that's going to use that library. So when you go to use these tools, you will create a main.c file that loads in the libfuzzer libraries and functionalities, and then also loads in the library that you want to go after, and you're going to paste those things together. So it is possible, so using this definitely requires the ability to build the code, and requires a little bit of bootstrapping on the part of the person doing the fuzzing to create this instrumentation. But it does allow for very targeted fuzzing that's very useful in terms of knowing you've got code coverage and doing unit tests and things like that. So it's very popular for those cases. And with these 4 different tools, there are some possibilities of chaining these things together. So you can use it with something like Redamsa or AFL if you want to get really fancy in your instrumentation. But these are like the 4 core ones that you'll see out there. Another thing that you will see as part of the choices you have to make is what sort of sanitizers you want to apply if you are going to build the code. And sanitizers are not something that are not compile flags that you would ever use in production. They have performance impacts. But again, similar to AFL and HongFuzz, when you compile the binary, they will add extra steps into the binary that make it easier to detect when things go wrong. So it can look for issues with memory addresses, thread race conditions, undefined behavior, control flow integrity and memory issues, like if you're trying to jump into uninitialized memory. And it finds these things by laying out the application in memory in unique ways, so it's more obvious when something goes wrong. And so it makes it easier to detect these issues. There's another sanitizer called leak sanitizer. It's typically not used for finding vulnerabilities, but it's used for finding memory leaks. And people will still use leak sanitizer because if you have a memory leak in the program, chances are you're not handling memory very well. And you want to, it's an indication that that's a section of code that you need to go into and clean up, even if it's not immediately obvious that it's exploitable. And so when you're looking at these tools, you want to have a strategy. If you don't have developer support and the code's too complicated for you to compile because there's too many dependencies or whatever, you're going to end up going with a black box approach. You're going to go with something like Redamsa or maybe AFL and HongFuzz in a black box mode. If you're really concerned about targeted unit testing, then maybe you invest in libfuzzer so that you can make sure that your fuzzing efforts are going after the sections of code that you're most concerned with. If you're not, then you can go, just across the entire binary, going for general health. Whatever you do, you want to start simple and build towards the complex. Don't try to chain libfuzzer and Redamsa together in phase 1. Start small. Make sure you've got something that works. See if you can get a couple of findings out of it. just doing the very basics with that tool. And then if you can confirm that you can find, a couple of crashes using it, then you can worry about scaling it later. So start doing some early experiments to figure out what combination of these tools is going to work right for your situation. Because ultimately, fuzzing is a part of the development lifecycle. So this is something I took from a Microsoft presentation that they did at CPPCon, which was a developer conference, when they were launching their scalable cloud-based fuzzing system, OneFuzz. And if you look at this diagram, you can see that they start fuzzing very early on. So all code starts with a pull request, which will kick off stack analysis. But right after that, if you are doing unit tests with something like libfuzzer, you can say like, okay, this check-in changed this part of the code. I know this part of the code correlates to this library. I've got a fuzzer that targets that library. So I'm going to do a build with these new code changes and immediately kick off a unit test against that to start fuzzing. So they will start fuzzing, right after the pull request. They'll do some attack surface analysis, and then they'll start applying those sanitizers, trying to find out, do they have memory leaks? Do they have other issues? And that occurs all before what they consider to be pen testing. So they will start the process very early on, and it is a part of their software development lifecycle. And then the next thing that you're going to consider, and something that's going to be in the mind of your arched eyebrow manager, is who's your project's customer. And the reality is that you are not the customer of the tool that you're deploying. You are ultimately there to support a development team or the overall organization. And so when you go to integrate this, you're going to have to work with developers, and then developers are going to have questions. They're going to be providing you the source code that's going to be the input to this tool. And then they are also going to be the consumers of the output of this tool. They ultimately have to fix the bugs, so they have to understand the stack traces that are involved. So the next phase of it is thinking about it from the developer's perspective, and they'll have a lot of questions about what the flow is going to look like. How are they going to get their binaries and their sample files into the fuzzing framework and distributed? And then, of course, once it gets distributed, how do you get that all centralized back? So how do you deduplicate issues when multiple fuzzers are finding the same things? How do you get notifications and bugs filed? Are those bugs going to be complete with the stack trace and the information to be able to reproduce this issue? The ability to reproduce an issue is really important for the developers. They may have questions about code coverage, like how much of my code have you covered? I haven't heard from you in a couple of days, so am I good? Right? What's the code coverage look like? Can I reproduce this in the original environment? If you're off in the cloud and you're fuzzing against Linux and you find a crash in Linux, and then they pull it back down to their Mac and they try to reproduce it on the Mac, they may not be able to reproduce the crash on the Mac because the Mac has a different CPU or is using different libraries. So they need to be able to have an instance of that original Linux instance to go reproduce this, this issue. And then, of course, you need to be able to make all of this accessible to the team. And you'll see this in the documentation for different tools. So I pulled this from the AFL GitHub, and they split up required tasks and optional tasks, but you can see that there are a bunch of decisions that need to be made, and either you're going to be the person who's making these decisions, or they're going to be the team that's making the decisions. And if they're making the decisions, you have to give them guidance on how to make those decisions. So, select the compiler. Is this going to be dumb fuzzing where you just use normal GCC, or are you using AFL's GCC? Are you going to apply the sanitizers? Are you going to modify the target in any way? You got to compile it. Then you got to prepare your campaign against it. So you got to collect the inputs. This is where you would typically do something like corpus distillation. And corpus distillation is where you take a large number of input files and you try to reduce it to the smallest set of input files possible while still maintaining maximum code coverage. That way you're getting the most use out of your fuzzing time, because you've reduced the number of inputs to a smaller set that's still going to allow you to have the same code coverage. Then you're going to run it, whether it's on your machine against multiple cores or across multiple machines. And then as it's running, you got to monitor the status. You got to check how the coverage is going, and you've got to be able to triage the crashes. I see the question about indicators of success. I'm going to talk about that in a little bit. So Ron, I am going to get back to your question shortly. And this is going to be an iterative process. You're going to start fuzzing. They're going to find issues. Hopefully they'll fix the issues. And then you're going to reevaluate the strategy. Do you apply the same selection of fuzzers and the same sanitizers as you did before to confirm the fix? Or are you running out of findings using this approach, and you're going to change up the way you use the fuzzer, or you're going to change up the input files, or you're going to change up the sanitizers that you're using? This is going to be an iterative process that you're going to go through. So be prepared to be the subject matter expert for the tool that you're selecting. The team's going to come to you with questions on it. Being able to guide the developer in doing the builds. You'll probably end up creating some supplemental documentation, either for things that the tools documentation doesn't cover, or you're going to be talking about team-specific information where the website talks about how to use the tool in general, but you have documentation about how we're going to use it internally. And then you're also going to want to develop a community for this, because you don't want to be the only person who can answer questions on this tool. So as you get developers educated about it, you want to have them in a community where they can help educate the developers who are still getting started in this process. So, okay, so you've got your plan. Now you're ready to jump forward. You're ready to go scale this out. And the tools I'm about to talk about, what's made a difference in the field recently that's made a lot of these tools more successful isn't the advent of the cloud. The cloud's been around for a while. You've always had the ability to run something across multiple machines. But it's the advent of API-driven services within the cloud that allows you to do direct automated bug filing, or have webhooks to get notifications on things. So webhooks for Microsoft Teams or Slack. It's the ability to have cloud-based authentication, so you can just authenticate using Active Directory rather than sharing a bunch of SSH keys. Build triggers, auto-scaling, API management. All of that's what's enabled the orchestration to exist to manage all these fuzzing jobs and answer those questions I mentioned earlier about, okay, how are you going to go spread this out across multiple machines? And then how are you going to get it all filtered back in and distilled and deduplicated and to the right owners? And there are two major cloud fuzzing platforms. One is Google's ClusterFuzz. This was publicly released by Google in February of 2019. It integrates with their cloud, which is GCP, Google Cloud Platform. And as of September 2020, ClusterFuzz had found over 25,000 bugs in Google's projects, popular tools such as Chrome. And it found over 22,000 bugs in over 340 open source projects integrated with the Open Source Security Fuzzing Initiative, which I'm going to talk about in the next slide. So obviously a very robust tool, very successful tool. They had deployed it internally for years before they released it publicly, and were very successful in tuning it to be able to find these bugs. On the other side of the world, there was Microsoft, and they were working on a project called OneFuzz. They publicly released that in September of 2020. It's obviously going to integrate with their cloud platform, which is Azure, but they had used it for continuous developer-driven fuzzing of Windows that allowed them to harden before they've done the latest shipments of the OS. And you sort of saw that in the funnel approach, or the funnel graphic I had shown earlier. In terms of using the free tier, you can run ClusterFuzz locally, I believe. And in terms of the free tier, I'm not positive. I'd have to double check on that. You can get some free tier compute, but I'm not sure if the other services you need are in the free tier. I'd have to check on that. But I'll see if I can follow up and answer that for you after the talk. So I mentioned the open source security fuzzing initiative. And what this is that, whether you're Apple, Microsoft, Google, Adobe, Netflix, we're all using open source libraries in our code. And Google wanted to help the community by offering up their fuzzing infrastructure to open source projects. And so, if you were OpenSSL, libjpeg, some sort of commonly used open source project, Google was going to help fuzz those environments. And so if you're a qualifying project, you would work with the OSS Fuzz team to write the fuzzers and get your build configs committed to the open source security fuzz branch in GitHub. Then their code builder would see that there are new projects available and new projects have been added. It would do a build based on your commits. It would place the binaries in Google Cloud Storage for temporary storage, where ClusterFuzz would eventually see them. And ClusterFuzz would go and download those binaries, orchestrate it out, get thousands of machines going and hammering on them, and then start outputting bugs into a bug tracker called Monorail. And then Monorail would notify the developer, hey, ClusterFuzz has found some stuff. Here's some things you can go fix. And then send it off to SheriffBot to make sure tracking happens around those bugs. And one of the things that you'll see in this diagram is that there's a lot of orchestration around ClusterFuzz to make this whole end-to-end thing happen. And that's one of the important things that you need to understand about the tools, and I'm going to be talking about later, is that when you go to your manager and they give you the raised eyebrow about deploying the tool, it may be because you're just looking at the tool, but the manager is thinking about this entire orchestration framework and what else is going to be involved. I have been working on deploying OneFuzz within Adobe, and just to give you some ideas of the features that it comes with is it works with AFL, libfuzzer, and Rodamsa, the three tools I mentioned earlier. They also made it compatible with the open source security fuzzing project, so they could also contribute to helping harden common open source libraries. It does the corpus merging, corpus distillation I mentioned earlier about being able to take those input files and get them reduced down to a finite set that maximizes coverage. It's deployed across Azure, so it's going to be using all the Azure technologies, functions for APIs, blobs for storage, scale sets for scaling these things up and down. And it supports reproducing in the original environment, because all you have to do is click and you get one more instance in the cloud that's the exact same environment for the developer to go reproduce in. The crash files are all stored in Azure blobs where they are redundantly backed up and available to everybody. It does a pretty good job of organizing the projects for you, and it's all controlled through a command line desktop. And to make all this happen is a fairly complex set of operations. Obviously, this text is too small for you to read, and I don't expect you to read it. The point of this slide is that it is complex. So if you want to go read this in detail, it's in the threat model that Microsoft published along with their project when they made it open source. But you can see here it's doing a lot of work for you. So even though it's going to require a similar orchestration framework that you saw in OSS Fuzz with ClusterFuzz, it is doing a lot of heavy lifting for you. These things are not simple to build. But the way it would work is you would go and you would hit make and build your libfuzzer implementation using Clang, and you would enable the address sanitizer for it. And then you would do a OneFuzz command line where you say, okay, I'm going to run a templated job for libfuzzer. I'm just doing a basic libfuzzer run. Here's some details about my project for tracking. Here's the target exe. And then it's going to do the rest. It's going to do all the other magic for you. So where you see it saying creating container, that's where it's creating containers in Azure Blob to store the inputs, to store the outputs, to store the unique reports, to store the code coverage. It's uploading your exe into the cloud. It's uploading all of your input files into the cloud. and it's kicking off that task. So once you do this, it's going to go take that exe you gave it, run against all the inputs, and start doing all the tracking of the job for you. And you can then run a different command line where you can track the status of all the jobs that you have going. So you can see how many pools of scale sets you have running. You can see the different jobs that are in place that you're running, and you can see all the different instances that are running. So it allows you to do that monitoring of the campaign that was you saw mentioned in the AFL slide. And then as things come out, you'll get your notifications. Okay, been running this for a while. Here's a crash I found. And so this is a Microsoft Teams notification. They can send notifications to other environments as well. But this notification gives you everything you need as a developer, because ultimately these things are going to go to a developer to reproduce the issue. Here's your reports. This was the specific version of the executable I was using while fuzzing. This is the specific build I was using. Here's my input file. Here's a command line if you need to repro in the initial environment. And here's your stack trace, so you know where in the call stack it crashed. So this is pretty much everything you need as a developer to be actionable once a crash is identified, once a vulnerability is identified. You've got your stack trace, you've got your reproducible conditions. So this is great, right? Problem solved. You've got fuzzing running in the cloud, you've got libfuzzer doing your unit tests. OneFuzz is doing everything by magic. The world's safe. Well, not necessarily, because like I said, these tools tend to require some supporting infrastructure. So for instance, in my scenario, while they did support filing bugs against certain targets, they did not support filing bugs against the environment Adobe was using. So I had to go and I had to build a bug filer that would go and monitor all those Azure containers and look for new issues and get them into the bug filing environment that Adobe was using. Also, I created a web portal and an API. You may have noticed from that command line that the command line wasn't necessarily intuitive. There's like a lot of fields you had to have memorized in terms of what order things go in. And so web portal makes it a little bit easier for people to manage the jobs. But more importantly, I was creating APIs. And I had mentioned earlier, the things that had made all the tools like ClusterFuzz and OneFuzz possible was API-driven development. So if I want to be able to kick off a job coming out of based on a GitHub check-in, it's much easier for me to have an API endpoint that I can hit with a simple web request to say hey, go kick off this job, than it is for me to install a command line tool into something like Jenkins or Circle CI and orchestrate a bunch of flags. Developers are much more comfortable with web API endpoints because that's sort of where they live. And I had to create documentation. So I had to create Docker files for them to do some local testing so that they could play with the tool locally. I created documentation about Adobe specific implementation, and then the teams I was working with also created team-specific documentation about how they were specifically using Adobe's implementation of the OneFuzz tool. So, when you go pitch this to a manager, they understand that the tool is free, but they're also looking at the overall cost to make this project happen, right? The cloud infrastructure costs to make it work, the time and resources it's going to take to build the web portal and the bug filing, the time invested with the development teams. They're looking for the total cost of ownership of this project, not the cost of one particular component. So that's something to think about when you're working with tools. And then in terms of measuring success, this was a question that came up in the chat. How do you know it worked, right? You want to be able to go to your managers and say hey, I deployed this thing and it was successful. And one of the obvious things to look at when you are trying to measure your success is, what was the false positive rate? How many bugs did we get out of it, et cetera. But there are other things that you would take a look at. For instance, did the bugs get closed, right? Ultimately, you're trying to improve the security of the software. So you want to make sure that um, the ability to get these bugs closed quickly is there. And so from your perspective, you can't actually write the patch in most cases. Whoever owns that library has to write the patch, but you are responsible for making sure that the developer has everything they need to be able to reproduce and debug the issue and to be able to retest, and that you're not the gating factor for why the bug's not getting closed. And so that's where OneFuzz's ability to, recreate via that command line that showed up in the Microsoft Teams message is important, because, and everything you saw in that message was important because that was everything a developer should need to be able to take in the issue and be able to execute on it. They had the stack trace, they had the original binary, they had the original input file, and if they needed to work in the exact OS that it occurred in, they had a way to do that through that connect command. More importantly is, did you identify trends? So whack-a-moling bugs is cool and all, but are you finding patterns that can help improve the software overall? So, are you finding things that the proactive team can then go and take and say, like, look, okay, you're obviously having data validation across the entire thing. Let's work on solving all of these bugs all at once by creating a good data validation library. Businesses have different ways of measuring success. There are KPIs, which are key performance indicators, OKRs, which are objective key results, NPS, net promoter score. Depending on what company you go to, they will have different ways of doing it, but they are going to ask you, what's the criteria for success? How do we know that the amount of money that we invested in this is paying off? And so is that going to be measured by code coverage? Is that going to be measured by developer adoption of how many people you were able to actually get to use the tool? Because that's an important indicator. So you're going to have to think about what the indicators of success are for your group. And can you build a community for the tool? If you can't get the developers to adopt it, it doesn't matter how technically cool it is, nobody's actually using it, and that's going to become a problem. So you do want to think about your success, what your indicators are for success around this. And then in terms of applying Scholastic skills in the real world, since you're all college students looking to get your first job, there were a lot of skills in this. And one of the things that sometimes comes up, especially on the proactive side, not so much necessarily on the reactive side or the pen test side, but definitely on the proactive side, is that it's easier to turn a developer into a security professional than it is to turn a security person into a developer. And part of that reason is your developer skills will help you understand the program and understand the root cause of the program. You're better at doing analysis, but also you have the ability to build the tools necessary to scale things out. And there was definitely a lot of building involved. During the course of this project, I had to be able to read the source code of the tool when the documentation was insufficient. I had to be, so this is source code that somebody else wrote that I had to be able to read. I had to understand it well enough that I could contribute patches back to the project, because I wanted to get these, because when I ran into bugs, I wanted to get them addressed quickly. And if you can help contribute the patch, it's addressed more quickly. I had to create the Adobe integrations I talked to you about the bug filing and the web APIs. And I had to work with developers on integrating the fuzzers. So I had to be able to talk to developers and work with them to set up these libfuzzer environments. So just to give you a couple of skills that I used during this, I used Kubernetes and Docker in order to create the web portal and the cron jobs, and also create simple test environments that people could use locally. Python for the OneFuzz command line, because that's what the OneFuzz command line is written in. Also, the OneFuzz function APIs were written in Python, and I used Python for my website and my bug filer. As far as the actual agents on the OSs that were orchestrating the actual fuzzing runs, those were all written in Rust. So I had to take a look at some Rust source code. I used knowledge of Azure cloud infrastructure, because that's where this was all deployed, and I needed to be able to manage that. I did some web development, React.js, HTML, and JavaScript for the web portal. The OneFuzz team is, I believe, currently working on changing their Azure Functions API from Python to C#. So I'm going to have to probably deal with C# a little bit more in the future. And then obviously C++ for libfuzzer. So there are a lot of development tools in this. Also, any tool you build has to be maintained. This is probably the last thing that your arch eyebrow manager is going to be thinking about, is a lot of projects are not just one and done and you move on. You have to, if you're going to get developers sold on this and using this as a part of continuous software development lifecycle, you're going to have to know how to maintain it and how hard or easy is it going to be maintained once it's stood up. And one other thing that can help you in terms of thinking about these projects when you build them is you're building a thing, right? So, and technological things come and go. You had records, then you had 8-tracks, then you had cassettes, then you had CDs, then you had DATs, then you had digital downloads via Napster and iTunes, and then you had Spotify as a streaming service. The thing you're building is a thing, and it will eventually have an end of life. But that said, if the tools that you build, if you build them right, you can reuse them in future projects. So some of the things that you're building, like that bug filer I built, I'm gonna have to file bugs for other tools in the future. That's something I can reuse. And I designed it in a way that it can be reused. So, you know, keep in mind that you sometimes can't get too emotionally attached to the things you build, but you can carry parts of them forward. So having said all of that, I probably freaked you out a little bit in terms of the complexity of this. To sort of calm your nerves, keep in mind that not everything needs to be working on day one. This is a project that's been taking me several months, and I could work on it as I go periodically. So if you didn't know everything, don't worry about it. It's not something that you have to be good at on day one. In terms of the rewards for the organization, obviously you're finding security bugs, but hopefully you're finding security patterns. You're finding things in the coding guidelines that can be improved. You're finding places to create centralized data validation libraries, et cetera. You know, as you're building this, you're going to create things that are reusable. As I said, the bug filer, something I can carry forward. And even if it doesn't completely work out, mistakes are okay if you can learn from them. Not every project you launch will be a raging success. I've launched projects before that turned out not to be a raging success. But I learned from them. There were some things I was able to carry forward from them, and it was able to make this happen. So just to sort of wrap up, since I'm out of time, there are several options out there for cloud-based fuzzing. If your company's just getting into it, I definitely encourage you to go out and use one of the tools that's out there. They all support different types of fuzzers with different configurations, so you have a lot of choices in terms of what you're able to do. So you're going to have to spend some time thinking about the strategy for how these tools will be applied, both from a technical perspective, but also what's the complete infrastructure going to be to make this thing happen and be an end-to-end solution, not just a tool. And then also who the customer of the tool is going to be, because ultimately you're there to support the development teams and to make the software that your company is making better. So, you know, always keep in mind that if the developers like it and the developers are using it, then it's going to be a successful tool. Security always involves a little bit of development. So even though you're a hacker, be prepared to have to tape together some code for different things here and there. And with that, I'll take any questions. Apart from the programming languages you listed, did you use assembly as well to dig deeper into the binaries? From a developer perspective, in terms of getting the fuzzer started, no, you don't necessarily need to know assembly level when you're starting. If at the other end of it, when you're doing analysis and you're trying to triage the bugs, and you're trying to figure out the severity, assembly will sometimes help. Or if you're trying to actually weaponize the vulnerability, because all these tools will just find crashes. And you know, depending on the type of hacker you're trying to be, like if you're a red teamer, you as a red teamer, you're not as concerned about whether the developers are going to fix the bug or not. You're there to help emulate real world scenario attacks. So you as a red teamer might need to know assembly to actually weaponize the bug, to turn it from a crash into something that can actually execute code. So assembly can help, but it's not, depending on how you're using the tool and how you plan to deploy it, it's not necessarily a requirement. It may be a requirement if the code's already written in assembly, like some teams that do programming for microwaves or Internet of Things or those types of things. They may write software that just starting at the assembly level. But you don't necessarily need to be an expert in assembly to be able to run these tools or to be able to set them up for your organization. Say we have a bunch of code, we want to get started on integrating fuzzing into the dev cycle. Any tips on picking out which code bases would be more likely to have issues first? Yeah, it depends on what the application does. So this is something where threat modeling can help, and thinking about the adversaries you have. So you're obviously going to start with where your files take input. So or specifically take input that the attacker can control. So in a phase one approach, you would look at the sections of code that are the initial triage points for the data that's coming in. So that might be one way of looking at it. You may look at the sections of code that are more critical. So if you're dealing with something, in a Windows environment or a mobile device or something like that, you may have sandboxes that are in place, and there's going to be a bridge between the sandbox where the untrusted code is executing and the more privileged area that has access to things like camera and microphone and the file system. And there's going to be a bridge that's linking those two. And so you may choose to target that bridge because you're going to say, okay, in this untrusted environment, there's going to be some bug in the overall application that the attacker is going to get control of. I know that there's going to be a JPEG issue. There may be an issue with a different third-party library. So they're going to get crashed and they're going to get code execution in this untrusted sandbox. And then they're going to try to escape that sandbox. And so rather than looking at the myriad of ways that they might be able to cause a crash in the overall application, which there may be a lot of, you're going to focus your fuzzing efforts on their ability to turn that crash into a privilege escalation. And so you look at the bridge between that sandbox and the more trusted environment, and you try to make sure that the attacker cannot break out of the sandbox once they have that initial crash. So you sort of take a look at the threat model for your application and try to identify the more critical areas. If you have sections of code which deal with more valuable data, you might target those because those are dealing with the most valuable data in the application. But your threat model would be a good start for figuring out where those places are and starting where the application most obviously is going to be taking inputs.
We have two more questions. We have Mohammed raised his hand. Did you get your question answered yet, Mohammed? And then we have Jeremy Smith.
Sure, I can take those.
So let's go with Jeremy first while we wait for Mohammed. Thanks, Peleus. One quick question. Does Adobe by chance have an entry-level position for software testing, quality assurance? This is the kind of job I'm looking for.
Yes. So pretty much every major company is going to have a jobs website, and now is a good time to be looking for them. If you wait until you graduate, the people who were a little bit earlier may end up getting the roles first. So start while you're in school, start applying while you're in school. All the different job sites usually have like an alert notification. So the jobs that are open at any one time, they come and go as they get filled. So you can subscribe to RSS feeds or at least notifications about jobs when they become available from that particular employer. Yes, in general, any large company is going to have a job, is going to have jobs like that open. Most large companies are constantly hiring. So the question really is, do we have a job open that interests you and plays to your skill sets? And I don't have your resume, so I can't answer that directly. But you can ping me on LinkedIn. Sometimes you can get in touch with the recruiters at these companies as well, and just start saying like, hey, I see you're a recruiter for this company. I'm definitely interested. You can reach out to them. So there's a couple of ways of getting your resume in there and getting it noticed. If there's a company that you definitely want to work for, start subscribing to the job feed subscriptions on their site, and you'll start seeing them. Or in LinkedIn, LinkedIn will allow you to subscribe to some of the job feeds as well. So yeah, Adobe is constantly hiring. There's usually several roles open at any one time. Okay, so Mohammed, do you have a question about defending against fuzzers?
Go ahead and use audio, Mohammed.
Oh,
Go ahead.
I heard you for a second and then you cut out.
Yep.
Sorry, I'm having some issues with Zoom. I'm using it on Linux, but it seems
okay. Well, I can hear you okay now, so why don't we go ahead?
Okay, so my question is about fuzzers. So it seems like they're pretty powerful since they kind of try to exploit every single possible, thing on the in a system. So how would you defend against them? Like, what would you do if someone is just trying to, let's say, wreak havoc on a company that they just bring in, like, does that, and they just want to create chaos in a sense.
Yeah, so fuzzers are very powerful, but there are limitations. There are bugs that fuzzers won't find. If it was possible to find all possible bugs via fuzzers, your iPhone wouldn't get popped because Apple does tons of fuzzing. There is a role for reverse engineers in the world because some things just can't be found by manually flipping bits. You have to actually get in there and read the source code because fuzzers have issues, finding certain things that require state or require a specific type of vulnerability class. So for instance, type confusion bugs are something that fuzzers aren't necessarily good at finding. But to get to your core question about how do you defend against them, it goes back to basics. It goes back to thinking about the application early on. It goes about thinking about how something's designed. So if you haven't started writing code yet, I would start by using a memory safe language that will eliminate a lot of the bugs. If that's not a possibility, and it's not always a possibility, then think about the architecture of the application. Can you create bottlenecks where the data all goes through one location? And then you can apply data validation at those bottlenecks. Do you think about how you empower the developers to create secure code? So this could be having stack analysis tools, which are helping flag things early in the process. It can be developer education, teaching them about things like prepared statements and SQL injection, teaching them about banned functions. If they're C and C++ developers, don't use string copy. You're looking for ways to empower the developers to create good code, and you're trying to orchestrate things to make it easy for the developer to do the right thing and make it hard for them to do the wrong thing. And so when you're designing certain applications, if you watch presentations about like Facebook and Facebook has a custom PHP. They don't use the normal open source PHP. They use a custom PHP. And one of the things that they customized in that language was trying to make it easy for the developers to do the right thing and hard for them to do the wrong thing. So you're looking at ways of empowering the developers. Just telling them they're dumb and why are they making mistakes doesn't really help. Doesn't help your relationship with them and doesn't help them get any better. So you want to have a close relationship with the developers and work with them on architecting the application in a way that will maximize its defensive capabilities. And so this is, if you hear the term shift left being used, this is where shift left comes into play.
All right, guys. Well, I'm sorry to cut it off, but your friend Leah, or the alumni, she's going to be having a presentation. Some of the
Yeah, she'll kill me if I bleed into her talk.
So yeah, we just made time. We're gonna have session 4. You're gonna have a few options, like Kevin and Leah. So go ahead and check those out. And thank you, Peleus, again for attending again. I know it was a lot of back and forth, but I appreciate you.
Yeah, no problem. I'm always happy to come.
All right, guys. See you then.
Bye.